Okay, so let us start today's session. In the last session, we have seen the Carnot cycle, right? In the last session, we have seen the Carnot cycle, right? At the same time, we have seen the reverse Carnot cycle, right? We have seen the reverse Carnot cycle. Okay, so now what we will do? Okay, see, now we will try to calculate the COP of refrigerator which works on a reverse Carnot cycle. Okay, so I will just go through that. Okay, we will calculate now the COP of, okay, we will calculate now the COP of now we will calculate the COP of, okay, the okay, just give me a minute. Okay, so let us start. Now we will calculate the COP of, okay, the refrigerator which works on the Carnot cycle. Okay, so for that I will just write down the expression. Okay, so just a minute. Okay, I will start sharing my screen. Okay, so now I will write down the formula for, okay, COP of, okay, COP of refrigerator, COP of the refrigerator, okay, working on, okay, working on reversed Carnot cycle, working on reversed Carnot, okay, cycle. Okay, so let us calculate the COP of the refrigerator which works on a reverse Carnot cycle, right? Okay, so I'll just write down it as, okay, I'll just write down that as COP of, okay, COP of refrigerator, COP of refrigerator, okay, which works on a reverse Carnot cycle. Okay, so I'll just indicate it like this. Okay, COP of the refrigerator which works on a reverse Carnot cycle. I will indicate it like this. Okay, so is given by, okay, is equal to, okay, I just need to put this sign, equal to sign, you can see, equal to, okay, is equal to, okay. So how to write down? All of you know the formula for COP. Okay, what is the formula for COP? Formula for COP is given by, okay, what desired effect you want, okay, what desired effect you want, okay, divide by, okay, divide by what work you supply, okay, divide by work input, okay, work input. Okay. COP is given by desired effect upon work input. Yeah, is that okay with this one? Yeah, COP is given by desired effect upon work input. Is that okay? Yes, all of you, is that okay?
Yes, sir.
I'll just rewrite this formula again. Okay, COP. Okay, what is the formula for COP? Formula for COP. Okay, as you can see, okay, it is the ratio of, okay, the desired effect upon work input. Okay, COP is given by, just write down that formula, desired effect, okay, upon work input. Okay, desired effect upon work input. Okay, so this is the formula for COP. This is the formula for COP, right? So how to write down that? Okay, as you can see now. Okay, COP is the desired effect upon work input, right? Now see, when we talk about the refrigerator, right? When we talk about the refrigerator, what desired effect we want? We want cooling. Okay, so as far as this refrigerator is concerned, okay, we are interested in cooling, right? What we want? We want cooling. Okay, so desired effect is nothing but cooling. Okay, that is what we want. Okay, in case of an refrigerator, right? In case of a refrigerator, we want cooling. Okay, so I'll just write down that desired effect. Okay, I want cooling. Okay, in a refrigerator. Okay, I want cooling in a refrigerator. See, you can see I want cooling in the refrigerator. Divide by work input. Work input obviously I will supply in the form of work. Okay, so work input I will supply in the form of work. Okay, so desired effect is the cooling divided by work input is a W, right? Work input is a W, right? Now see, so let us write down that. Okay, so for that, so cooling, see all of you can see when you see the formula diagram for the reverse Carnot cycle, you can see the formula for the reverse Carnot cycle. Okay, so in the reverse Carnot cycle, you can see that QR amount of heat is rejected. You can see this. Okay, this QR amount of heat is rejected. Can you see this QR? QR is the amount of heat rejected, and QS is the amount of heat supplied. Okay, so this QR is the amount of heat rejected. QS is the amount of heat supplied. See, supplied is nothing but what? Received. Okay, so amount of heat supplied. Okay, if you want, I'll just write down here. Okay, the QS. What is QS? QS is nothing but heat supplied. Okay, QS is nothing but heat supplied or heat received. Okay, or you can call this as heat received. Okay, or also you can call this as heat abstracted or extracted. You can call that. Okay, you can call that heat abstracted. Okay, I'll just again start that. Okay, so this is nothing but heat supplied or heat received or heat. Okay, we used to call this as heat abstracted, right? Is a heat abstracted. Okay, so how much heat it is supplied or how much heat is received, okay, or how much it is abstracted, okay, that is nothing but QS. Okay, so that is called as QS. Okay, so obviously the QS is a heat abstracted. Okay, and what happens in the refrigerator is in refrigerator heat is abstracted, right? Whatever the food atoms that you keep in a refrigerator, okay, what happens inside the refrigerator? Okay, the heat is abstracted, okay, from that food atom. Okay, so here we are interested in QS. So QS amount of heat it is abstracted in the refrigerator, right? QS amount of heat it is abstracted in the refrigerator, right? So what happens with QR? Okay, can you see this value QR? You can see this QR, right? QR. So QR is the amount of heat rejected, and where the heat is rejected in the refrigerator. Okay, so when you observe the temperature at the outside of the refrigerator or at the back of the refrigerator, you might feel some temperature, right? So that is rejected. So what happens in the QS is abstracted, right? QR is a rejected, right? So let us so obviously the value of QS will give me the cooling. Okay, QS is the heat abstracted and QR is the heat rejected. So heat is abstracted in the refrigerator and heat is rejected outside the refrigerator. Okay, so QS will give me cooling. Okay, because when you abstract the heat, then only that atom gets cooled. Okay, then only that atom gets cooled. Okay, So if you want, okay, I'll just write down one more formula for COP. Okay, so QS, obviously it will give me cooling. Okay, so QS, it is related with the cooling. QS is related with the cooling. Okay, so this cooling will be nothing but in terms of QS. Okay, so for QS, okay, this cooling I will replace by see, cooling I will replace by QS. Now what is W? W I want, right? I want the value of W. Okay, so how to calculate the value of W, all of you? Okay, W, how to calculate work done? Okay, so all of you, you know the formula for work done, right? What is the formula for work done? Okay, W is given by, how to write down W? Okay, W is always what heat is supplied minus what heat is rejected. Okay, that is basic formula for W. Okay, see, W is nothing but work. Okay, W is a work. Okay, but this is a cycle, right? Whenever it is a cycle, okay, net work is equal to net heat transfer. Net work transfer is equal to net heat transfer, right? Try to understand. W is nothing but a work. Okay, but when you see this, okay, it is a cycle. It is a cycle. Okay, so what happens in the cycle? Okay, net work done is equal to net heat transfer, right? Net work is equal to net heat transfer. So in that case, we can calculate W is equal to Q. Okay, because it's a cycle. So when system executes a cycle, heat transfer is equal to work transfer, or work transfer is equal to heat transfer. Okay, so W is equal to Q. Okay, now what is Q? Okay, it is nothing but what is net heat? It's the difference between heat supplied and heat rejected. It's the difference between heat supplied and heat rejected, right? Now see, when you talk about the devices like refrigerator, when you talk about the devices like refrigerator, what happens is always more amount of heat rejected as compared to heat received. Okay, so I'll just write down the formula for W as, okay, heat rejected, okay, heat rejected minus heat, okay, received. Okay, you can see that I've written the formula as heat rejected minus heat received. Why I've written this formula? Okay, because see what happens, see, when you see the diagram, okay, for the refrigerator, okay, always you find that heat rejected, it is always greater than heat received. Okay, that is the reason why I have written the reverse formula. When you talk about the engine, when we talk about the engine, it is heat received minus heat rejected. Because what happens in the engine, okay, out of some heat receives, okay, some heat engine rejects. Okay, out of some heat receives, engine rejects some amount of heat, right? But this is not the case in the refrigerator. What happens in the refrigerator? In the refrigerator, more amount of heat is rejected as compared to the heat received. Okay, so I have written the reverse formula. Is that okay? Yes, is that okay with this formula? Let me know. Yeah. Yes. Is that okay with this one? Or you're not able to understand? Let me know that.
सर एक और बार बताइए ना.
Yeah, see, I will just go to the, okay, I will explain you, okay, what is that? Okay, let us see that. Now what thing I'm telling you, okay, just try to understand. Okay, let us see, okay, let us see the example of, okay, let us see the example of engine. Okay, let us talk about the engine. Okay, let us talk about the engine. Okay, so let us talk about the heat engine. Let us see what is heat engine. Okay, so what heat engine is doing, all of you? Okay, how heat engine works? Okay, so this is the engine. Okay, so let us see that. Okay, we have one temperature reservoir. We have one more temperature reservoir, that is T2. Okay, see here, all of you. I'll just show you that. Okay, so see, we have one reservoir, okay, which is at a temperature T1. Okay, we have one more reservoir which is at a temperature T2. Okay, and what we have engine in between, right? We have engine in between. So what this engine is doing, it is receiving, okay, it is receiving Q1 amount of heat. Okay, it is rejecting Q2 amount of heat. Okay, and while doing so, engine is producing W is equal to Q1 minus Q2 amount of work. Is that okay? Yes.
Yes, sir.
Is that okay with this one?
Yes, sir.
Okay. Now, can you say that, okay, this value of Q2 is less than Q1? Yes? Yes? Because see, Q1 is the heat received and Q2 is the heat rejected. Okay. So what happens out of Q1, okay, let us take the example. Okay. Let's say the engine is receiving 50 kilojoule of heat. Okay. Out of 50 kilojoule, 30 kilojoule it converts into work, and let's say 20 kilojoule is rejected. Is that okay? Yes. Is that okay? Out of 50,
Yes, sir.
the engine converts only 30 kilojoule of heat into work. Engine is receiving 50 kilojoule, but out of 50 kilojoule, it converts only 30 kilojoule into work. Okay. What is about rest of the 20 kilojoule? It will reject. Okay. So what you can observe that amount of heat rejected, it is always less than amount of heat receives. It receives 50, out of 50, it converts 30 into work, okay, and 20 it rejects. Okay, so amount of heat rejected, it is less than amount of heat received, right? Is that okay with the engine?
Yes, sir.
Is that okay with the engine? Okay. So now let me explain you. Okay. Now let me explain you about, okay, the what happens in the reverse heat engine. Okay. So just see here, all of you. Okay. So see here, all of you. Okay. Let us see about what happens in the reverse heat engine. Okay. So let us see what happens in the reversed heat, okay, engine. What happens in the reverse heat engine? Okay. So let us see that. Okay. So let us consider. Okay. Let us consider this reverse heat engine. Okay, which operates between the same temperature limits. Okay, this is T1. Okay, all of you can see that. Okay, so let us see that this is at a temperature T1, right? All of you know that this is at a temperature T1. This is at a temperature T2. This is at the temperature T2, right? You can see that. Is that okay? Now what? See what we have. We have reversed heat engine. So obviously it will operate in a reverse direction. So this is a reverse direction in which, okay, it is operating, right? So what this reverse heat engine will do? See, this reverse heat engine, okay, will abstract some heat. Okay, will abstract some heat. Okay, so how much heat will abstract? It will abstract Q2. Okay, and how much heat? Okay, see, if you want this reverse heat engine to abstract Q2 amount of heat, okay, obviously we need to supply W amount of work, right? So until and unless you supply, okay, until and unless you supply W amount of work, engine will not abstract Q2. Okay, engine will not abstract Q2. So when you supply W amount of work, the engine will abstract Q2, and as a result of that, okay, engine will deliver. How much it will deliver? It will deliver Q1, because with respect to T1, it will deliver Q1. And how to calculate Q1? Okay, how to calculate Q1? It's addition of Q2 plus W, right? Q1 is addition of Q2 plus W. You can see. Okay. Now question here. Now you can say that. Now see all of you. Here Q1 is greater than Q2. Is that okay? Yes or no? That means, okay, you can see what is Q1? It's the addition of Q2 and W. Okay, so obviously in Q2 you are adding W, that's why you are getting Q1. So obviously Q1 is greater than Q2. Yes or no? Yes. Yes. Is that okay?
Yes, sir.
Okay. Now, so what I need to convey is heat rejected is greater than, okay, heat received. Is that okay? All of you. Heat rejected is greater than heat received here, because it's a reverse heat engine, right? What happens?
Yes, sir.
What happens in the previous? Okay. What happens in the previous slide? Okay. What happens here? You can see that. What happens here? Here, what we got? We got that heat. Okay, this is what? Heat rejected. okay, is less than heat received. Yes or no? Okay, in the heat engine, what we got? Okay, heat rejected is less than heat received, right? But here, okay, in reverse heat engine, what we got? Okay, heat rejected is greater than heat received. Is that okay? Is that okay now, all of you? Yes. Yes. Is that okay? All of you?
Yes, sir.
Let me know. Okay. So
Yes,
that is the
sir.
reason why, okay, I have taken, you can see, I have taken that heat rejected minus heat received. Okay, that is the reason why I taken like this. Heat rejected minus heat received. Because what happens in the refrigerator, okay, is always more amount of heat rejected, okay, as compared to heat received, right? So that is what is written. Okay, now let us see the diagram. Okay, now let us see the diagram. So how to calculate W? Okay, heat rejected. So heat is rejected during which process? You can see during which process? During 2 to 3, right? Yes or no? Heat is rejected during which process? It is during 2 to 3, right? Okay, minus heat is received during which process? Just see this reverse Carnot cycle, all of you. And heat is received during which process? All of you.
1 to 4.
Right, it is 4 to 1. Okay, just a correction. It's a 4 to 1, right? Not
Yes, sir,
1 to
yes, sir.
4. You can say it's a 4 to 1 process.
The direction 4 to 1.
Yeah, direction just you're just okay. So heat rejected it is during 2 to 3 minus heat rejected it is during a 4 to 1, right? So what I will do, okay, now I will put these values. Okay. So what I will get? I will get COP of same formula, COP of refrigerator works on a reverse Carnot cycle is given by, okay, see cooling. What is cooling? As I told you, the QS will give me cooling. Cooling will be given by heat supplied. See, don't understand. See, heat supplied means heat received or heat abstracted. So obviously, in refrigerator, QS amount of heat will be abstracted. Okay, divided by work input. Okay, divided by work input. Okay. So see here, all of you. Okay. So see here, all of you. Okay, divide by what is work input? I just written that. You can see that. Okay, what work input are written? QS.
Q1 minus Q2.
Right. See here, I can write down as Q223 minus Q421. Right? Yeah, is that okay? Yes. Is that okay? Yes, all of you. Yes. Is that okay with this one?
Yes, sir.
So see all of you here. Okay. Now, can you tell me during which process heat is supplied? Can you tell me during which process heat is supplied? All of you. Can you just tell me
Adverse heat engine.
during which process heat is supplied or received? Obviously, it is during 2 to 3, right? Obviously, it is during
2 to 3.
yes, it is during 2 to 3. Yes, I'll just write down here. Okay, see all of you, just see here. If you want, I'll just rewrite that formula. Okay, I find that some of you are not able to get that. Okay, so I'll just write down that formula. So is equal to, see, heat is rejected during which process? During 2 to 3. So it is Q. You can see that. Okay, it is Q2 to 3 minus heat rejected received. Okay, it is during 4 to 1. Right? It is received during 4 to 1, right? See, you can mute 4 to 1, right? So now I'll put that formula. Okay, so now what I'll write down? COP of, here all of you, COP of refrigerator which works on a reverse Carnot cycle is given by, okay, is given by what? Cooling. Cooling. Okay, so as I told you, cooling will given by heat supplied, and heat is supplied during which process? Okay, so I'll just write down. Okay, heat is supplied, that is during which process? So heat is supplied during process, okay, Which process? Can anybody tell me? During 4 to 1, right? So during 4 to 1, heat is supplied. Okay, so COP of refrigerator is given by, okay, Q4 to 1 upon okay, Q2 to 3 minus Q4 to 1. Yes, is that okay? Yes. Let me know. All of you.
Yes,
See, this is very important, huh? See, heat is supplied. See, what is cooling? Cooling will be given by heat supplied. And during which process heat is supplied? That is during 4 to 1, right? Upon work is Q2. Yes. All of you. Is that okay with this one? Yes.
Yes, sir.
All of you, is that okay?
Yes, sir.
Okay. Now see, all of you try to understand. Now this is a Carnot cycle, right? This is which cycle? This is a Carnot cycle. Okay. So simply you can replace the heat by temperature. We can replace the heats by what? We can replace the heat by temperatures. Okay. So see this 4 to 1, you can see this diagram. In the diagram, you can see, okay, the process 4 to 1, during 4 to 1, what happens? The temperature is constant. That is T4 is equal to T1. You can see during 4 to 1, temperature is constant. That is T4 is equal to T1. Okay. So this Q4 to 1, I will replace by any of the temperature. I will just write down this as T1. Okay. See, because in Carnot cycle, what happens? The efficiency of Carnot cycle only depends upon the temperature. So simply you can replace the heat by temperature. So during process 4 to 1, you can see in the diagram, okay, this is a process 4 to 1. Okay, so 4 to 1 process is carried out at what temperature? It is carried out at a temperature T4 is equal to T1. Process 4 to 1, it is carried out at a temperature T4 is equal to T1. Okay, so that is the reason why, okay, this heat I have replaced by temperature. Okay, divide by, you can see, divide by okay, yeah. So see here, all of you. So T1, okay, divide by, okay, what I should write down? T1 divided by, okay. Now let us see the process 2 to 3. Process 2 to 3. Can you see the process 2 to 3? Okay, it is carried out at what temperature? T2 or T3. So simply I'll just write down this as T2. Okay, minus again process 4 to 1. It is again carried out at what temperature? T1. Okay, process 4 to 1. It is carried out at what temperature? T1. Okay, so similarly I will just write down that, right? Similarly I will just write down that. So T2, okay, minus T1. T2 minus T1. Is that okay? Have you understood the formula? 4 to 1, it is carried out at a temperature T1. So I have written it as a T1. Okay, Q2 to 3, it is carried out at a temperature T2. So I just replace by T2. Yeah. Is that okay with this one? Yeah. Okay. See, is that okay? All of you, is that okay?
Yes, sir.
Okay, so see how to understand or how to remember the formula. So if you have a refrigerator, which works on a reverse Carnot cycle, okay, how you will calculate COP? Okay, you can see it's T1, right? T1. What is T1? T1, you can see temperature T1. Okay, it's a minimum temperature. You can see in the diagram. T1 is the minimum temperature. You can see the TS diagram. So T1 is the minimum temperature, T2 is the maximum temperature. Okay, so further you can write down the formula for this as, okay, T minimum, right? I'll just write down that T minimum. Okay, just a minute. Okay, T minimum, okay, divide by what we have? We have T max. Okay, we have T max. Okay, just a minute. We have T max minus T mean, right? Minus T mean. Is that okay? Yes. Is that okay or not? What do we have? We have the formula for is that okay or not? Let me know. What formula we have? We have 1 minus T minimum divided by T max minus T minimum. Yeah, is that okay? Yes. Is that okay?
Yes, sir.
Have you understood this from where it is derived or how to remember the formula? Yes. Have you understood?
Yes. Yes, sir.
Yes. Okay, so this is basically what? It's a okay, it is nothing but what? Okay, T, okay, T mean divided by T max minus T mean. T mean divided by T max minus T mean, right? Yeah, is that okay? Yes. Is there any doubt with this one? Yes. Is there any doubt with this one? Have you understood this? Yes. Have you understood? Yes. Is that okay? Yes. Is that okay or not? Let me know. Yes, all of you. Is that okay?
Yes, sir.
Okay. Now let us go to the next case. Okay. Now let us go to the next case. Okay. What we can have, we see now what we have seen is a refrigerator, right? Now what we have seen, okay, is basically the refrigerator, right? So on the similar line, okay, same like a refrigerator, okay, can we have a heat pump for that? Okay, is that okay or not? Same like a refrigerator, we can also have a heat pump. Okay, so now I will just write down, okay, the COP of, okay, I'll just write down COP of, okay, heat pump, COP of heat pump, okay, working on, okay, reversed, working on reversed Carnot cycle. Okay, working on reverse Carnot cycle, right? Let us calculate the COP of heat pump now, okay, which works on a reverse Carnot cycle, right? So how to calculate that? Okay, can anybody let me know that? How to do that? Can anybody let me know that? All of you, okay, how to do that? Okay, now see what is the difference between heat pump and refrigerator? In refrigerator, we are interested in heating, sorry, cooling. In refrigerator, we are interested in cooling. While in case of an heat pump, we are interested in heating, right? So I'll just write down the formula for COP. Okay, so COP, I'll just write down COP, okay, of the refrigerator, of the heat pump, okay, COP, just a minute. Now I need to write down the formula for COP, right? Try to understand. This now why I'm giving this time is you should be able to understand, because based on that we need to take the problems. So COP of heat pump which works on a reverse Carnot cycle. So how to write down COP, formula for COP? Okay, what is the formula for COP? You know that. Okay, it's again desired effect. Okay, formula for COP is a desired effect. Okay, upon what? Work input, right? Desired effect upon work input. Basic formula written. Okay, now what is the desired effect in case of a heat pump? Okay, we want heating. Okay, what we want? We want heating, right? Upon what is work input? Work input, I have written that as a W. Same work input, I've just written that as a W. Okay, now see, what is heating? Heating, we want heating. Okay, so the term, okay, I'm interested to write down the value of heating. Okay, which heat will indicates that, okay, the heat is heated, right? You can see that. Right. Now when you see the diagram again, see when you see the diagram again in a reverse Carnot cycle, okay, you can say that See, QS is giving me the cooling. Okay, if QS is giving me the cooling, obviously QR will give me heating, right? So what is QR? I'll just write down here. QR, okay, is a heat rejected. So heat rejected is the QR, right? Heat rejected is nothing but a QR. Okay, and obviously this QR, it is responsible for heating, right? Because see, QS was giving cooling. See, QS was giving cooling. So obviously the heat which is rejected will give the heating, right? And this rejection, it is done during which process? It is done during process 2 to 3, right? The heat rejection, it is done during 2 to 3. Okay, now what is W? Okay, as like last, okay, as like we have seen it for refrigerator. W, it is same. It is obviously heat rejected, okay, minus heat supplied, right? Heat rejected minus heat supplied, right? So I'll just write down that formula as heat rejected. During which process heat is rejected? Okay, during 2 to 3, minus, okay, heat is supplied during which process? Okay, during 4 to 1. Heat is supplied during which process? During 4 to 1. Okay, so I'll just now write down the formula for COP of heat pump which works on a reverse Carnot cycle is given by, okay, so heating term, okay, I need to write down as Q2 to 3. You can see Q2 to 3 upon what done is W, that is Q2 to 3 minus Q4 to 1 minus Q4 to 1. Is that okay? Yes. Is that okay with this one? Yes. Yes, all of you. Is that okay? Only the numerator I have changed. In the refrigerator, I have taken QS in the numerator, okay, and in the heat pump, I have taken QR in the numerator, right? The only thing change, okay, these are the only changes. Now see, with respect to Q2 to 3, you can see the Q2 to 3 process. You can see the process Q2 to 3, okay, on the diagram. Okay, so see this Q2 to 3, it is done at what temperature? It is done at T2 or T3. Okay, so simply I'll just write down here T2, okay, divide by, okay, again Q2 to 3, it is done at a temperature T2 minus, okay, Q4 to 1. Q4 to 1, you can see it is done at what temperature? Q4 to 1, it is done at temperature T1. Okay, so minus T1. Is that okay? Yeah, all of you. Yeah, is that okay with this one or not? Let me know. Yes, all of you. Is that okay?
Yes, sir.
Okay, so see all of you, how I should write down the formula again? I can write down the formula like this. Now you can see the T2. You can see in the TS diagram, T2. T2 is the maximum temperature. Okay, so I'll just write down here. T2 is the maximum temperature. Divided by, you can see T1. T1 is the minimum temperature, right? T1 is the minimum temperature, right? So this is T1 is T minimum. Okay, minus T maximum. Okay, you can see that, right? So see, how to calculate COP of heat pump, okay, which works on a reverse Carnot cycle. Okay, so how you'll do that? It is, okay, maximum temperature divided by maximum minus minimum. Okay, divided by maximum minus minimum. Okay, I'll just erase that. Here it is. Okay. Just give me a minute. Okay, so see here, all of you. Okay, so see here, all of you. What formula written for that? All of you.
सर स्क्रीन नहीं दिख रहा.
Yeah, I'm showing that. I'm showing. Yeah. Just a minute, just give me a minute. Yeah, all of you can see that. Okay, just a minute, I will share my screen. Since there are sometimes there are some technical difficulties. Okay, yeah, but we need to encounter those, right? So see here, all of you. So this formula, okay, I'll just erase that. So see here, how we can write down this formula? Yes, how we can write down this formula? See, as I told you, okay, it is a T max, okay, minus T mean. Okay, this is to be written at T max minus T mean, right? T maximum, always we have maximum minus minimum temperature, right? Is that okay? Is that okay, all of you? Yeah. Yes. So if you just go to the previous slide, okay, when we go to the previous slide, okay, let us see what was the formula. Okay, when you see the formula, what was the formula? T mean divided by T max minus T. Okay, in the numerator we have T mean. Okay, in the denominator we have same term, that is T max minus T mean, right? Okay, but when you come to the heat pump, okay, in the numerator what we have T maximum. Yeah, we have T maximum. Okay, so this is the only change. Okay, in the refrigerator, in the numerator we have minimum temperature. In the heat pump, in the numerator we have maximum temperature, right? So this is the only change. Is that okay? Yeah. Yes, all of you. Is that okay? Yes, all of you.
Yes, sir.
Okay. Now let us move to the next session. Okay. Now let us calculate. Okay. Now see, initially we have started with the refrigerator. Try to understand. We have, after that we have seen heat pump. Okay. But we have yet not, okay, done with the heat engine. Okay, because we have three devices: heat engine, refrigerator, and heat pump. Okay, heat engine, refrigerator, and heat pump. Okay, so let us calculate the now for the heat pump. Okay, so how to do that? Okay, all of you know that for heat pump we need to calculate what? We need to calculate. Okay, for heat pump we need to calculate what? We need to calculate efficiency. Okay, so I'll just indicate it like this. Okay, so I'll just calculate now efficiency. Okay, so I'll just write down efficiency of okay, heat engine, efficiency of heat engine, efficiency of heat engine working on, you can see efficiency of heat engine working on reversed Carnot cycle, efficiency of engine working on reverse Carnot cycle. Okay, so let us calculate that. Okay, so I'll just write down here efficiency of engine, okay, engine which works on reverse Carnot cycle is given by, okay, how to do that? Because see, it is an engine. For engine we can't calculate COP. Okay, COP you can calculate only for a reverse heat engine. See, this is heat engine. Okay, for a heat engine we need to calculate efficiency, and if it is reverse heat engine, okay, like refrigerator or heat pump, so for that we need to calculate COP, right? For that we need to calculate COP. Now we are dealing with the engine. Okay, so we will calculate its efficiency, and that engine is working on a reverse Carnot cycle. Okay, it is not on an ordinary Carnot cycle. Okay, it is working on a reverse Carnot cycle. Okay, so in the last lecture we have seen the difference between Carnot and reverse Carnot, right? So just see that. Okay, so efficiency is given by, okay, what work it is done, okay, upon what? Upon, see, you can say efficiency of Carnot engine. Okay, reverse Carnot engine. Okay, how to do that? So it is work done, okay, upon now what to do? Okay, it's a heat rejected. You can see work done upon heat rejected. Okay, so work done, which the process during which the work is done. Okay, it is during 2 to 3. Okay, so during process 2 to 3 the work is done, you can see. Okay, see, work done, all of you, work done. So work done, it is difference between what heat is supplied, Okay, and see all of you try to understand. It is a reverse Carnot engine. It's a reverse Carnot engine. So what is the efficiency? Okay, work done upon what? Heat. Work done upon heat. Okay, rejected. Work done upon heat, rejected, right? Now see all of you, work done upon heat, rejected. Now what is work done? Okay, just now here we have seen. Okay, above you can see work done is what? Heat rejected minus heat supplied. Okay, so I'll just write down this. Okay, heat rejected. Okay, I'll just write down that. Okay, so work done is what? Heat rejected. Okay, minus what? Heat supplied. Okay, heat supplied, right? Upon heat rejected. That is Q2 to 3. Try to understand, huh? Because see, this is a reversed. Okay, this is a reverse Carnot cycle. Okay, so we need to take. Okay, work done as what? Okay, work done is heat rejected minus heat supplied. Okay, because what happens? Okay, more amount of heat is rejected as compared to heat received. You can see heat is rejected during which process? 2 to 3. Heat is rejected during which process? During 2 to 3. So if you calculate the area below 2 to 3, it will give you heat rejected during 2 to 3. Okay, see, because we are plotted the process on a TS diagram. So when you plot any process on a TS diagram, area below that process, okay, will give you heat. So if you need to calculate what amount of heat is rejected during 2 to 3, what amount of heat is rejected during 2 to 3, simply calculate area below 2 to 3. Okay, so heat rejected during 2 to 3 is area below 2 to 3. Similarly, heat supplied during 4 to 1, it is area below 4 to 1, right? It is area below 4 to 1, right? So you can see area below 2 to 3, it is greater than area below 4 to 1. That means heat rejected during 2 to 3, it is greater than heat rejected during 4 to 1. Is that okay? Yes. Is that okay? Because see, always we used to
Yes,
write down
sir.
the formula as heat supplied minus heat rejected. Okay, but here I have written that heat rejected minus heat supplied. The reason is that, okay, more amount of heat is rejected as compared to heat supplied. Yeah, is that okay? Now, yes, yes, all of you. So can we write down this? So is equal
Yes.
to, okay, what is the temperature during 2 to 3? You can see during process 2 to 3, what is the temperature? It is T2 or T3, right? All of you, during 2 to 3, what is the temperature? It is T2, right? It is T2. Minus during 4 to 1, what is the temperature? It is T1. Okay, you can see in the diagram. See, during this process 2 to 3, see, this is a 2 to 3 process. So during 2 to 3 process, okay, during process 2 to 3, what is the temperature? T2 or T3. So I just written that as a T2, right? During process 4 to 1, what is the temperature? That is T1 or T4. So that I written as a T1. Upon during 2 to 3 is T2, right? It's T2. Is that okay? Yes. All of you have understood?
Yes, sir.
Yes, sir.
Okay. So you can see what COP of heat pump, you got it when it operates on a reverse cycle. It is T2 upon T2 minus T1. And here what we got? T2 minus T1 by T2, right? So it is nothing but, okay, it is nothing but 1 by, okay, COP of heat pump, COP of heat pump, okay, just a minute, COP of heat pump, okay, which works on a reverse Carnot cycle, right? Okay, which works on a reverse Carnot cycle. I'll just write down that. Okay. So it is nothing but COP of, okay, heat pump. Just a minute. There are some technical difficulties. Yeah. So it is 1 by COP of heat pump, COP of heat pump. Okay, just a minute. a COP of heat pump which works on a reverse Carnot cycle. Okay, is that okay? Which works on a reverse Carnot cycle. Yes. Yes, is that okay? Have you understood this? Yes, all of you have understood this one.
Yes, sir.
सर
Yes, yes,
नेक्स्ट लेक्चर का टाइम हो गया साकिब सर ज्वाइन करने बोले सेशन
yes, yes. Is that okay? Yes. Can we conclude the session, all of you? Is that okay?
Yes, sir. Yes.
Have you
यस
understood?
सर
Yes,
Yes, sir.
Is it okay with the today's session? Yeah. So in the next session, what we'll do? Okay, we will start the problem based on the reverse Carnot cycle. Yes. In the next lecture, we will start with the problem which is based on the reverse Carnot cycle. Okay. So